Welcome to this explainer. I am absolutely thrilled you're here today because we are going to demystify a topic that is, quite literally, flying right over our heads. If you've ever tried to read up on modern aviation, you've probably hit a wall of incredibly complex jargon. I mean, it's like a totally different language. Well, fear not. We are pulling directly from the definitive, exhaustive source on this topic, the Handbook of Unmanned Aerial Vehicles, to unscramble this alphabet soup. We're going to break down exactly how global agencies classify, define, and regulate the skies.
Okay, let's dive right into this. Have you ever noticed how the Department of Defense, the Federal Aviation Administration, and international bodies like the ICAO all seem to use completely different terms for the exact same flying machines? You'll hear drone on the evening news, UAV from an aerospace engineer, and UAS from a regulator. It's incredibly confusing, right? But here's the thing, these aren't just interchangeable buzzwords. These different terms actually stem from vastly different requirements, legal frameworks, and even military versus civilian concepts.
So here is our roadmap for today. 1. The drone name game. 2. Unpacking the alphabet soup. 3. Key aviation terms. 4. Classifying unmanned systems. And 5. The future of flight.
Part 1. The drone name game. From pilotless to systems.
First off, we need to tackle the fundamental difference between the flying vehicle itself and the entire operational system that actually keeps it in the air. UAA stands for Unmanned Aerial Vehicle. This strictly refers to the pilotless aircraft itself, the actual flying machine with a total absence of an onboard human pilot. But notice the shift to UAS, Unmanned Aircraft System. The U.S. Department of Defense and the FAA introduced UAS to emphasize that we aren't just talking about a flying piece of hardware. The system includes the ground control stations, the communication links, and the launch and retrieval mechanisms. When you say UAS, you're legally and functionally acknowledging the entire massive infrastructure required to make that aircraft fly safely.
You know, history heavily shapes our language. Back in the Vietnam War era, they were called RPVs, or remotely piloted vehicles. Later on, the U.S. military shifted to RPA, remotely piloted aircraft, to explicitly include the pilot in the terminology. And today, the UK and the International Civil Aviation Organization use RPAS, remotely piloted air system. Why the change? Because regulators absolutely want to emphasize the man in the loop. Even if the aircraft is literally miles away, there is always a human responsible for it.
Section 2. Unpacking the alphabet soup. Chapter 3. Definitions. We are going to dive straight into Chapter 3 of the Handbook now, unscrambling the specific common terms that dictate how these systems actually operate. When you lay these definitions out side by side, it's fascinating. Let's break down operational control. A GCS is your ground control station, that's the off-board command center. But the real game changers here are LOS and BLOS. Line of sight means you have direct visual or radio contact with the aircraft. But beyond line of sight, or BLOS, that drastically changes the operational complexity. To fly BLOS, you suddenly need forward and return links bounced off satellites. The vocabulary literally defines the engineering requirements. And when we look at the scale of these systems, MTOW, maximum takeoff weight, is not just technical jargon. It's absolutely the most crucial metric for measuring the kinetic energy and therefore the risk of a ground impact. Then you have your SUAS, or Small Unmanned Aircraft Systems, which your local hobbyist might fly around the park. And at the absolute cutting edge, we have the MAV, Micro Air Vehicle. These are so cool. They're short-range systems, often used by military special forces, that can literally be disassembled and carried in a standard backpack.
Part 3. Key aviation terms. Who and what is at risk?
Let's shift our focus for a second from the hardware over to the human element. The role of a visual observer is a great reminder that even unmanned flights still require human eyes. A visual observer is a required flight crew member whose job is to assist the pilot in command to avoid mid-air collisions, watch out for clouds, obstructions, and tricky terrain. Unmanned simply means no one is in the actual cockpit. It definitely doesn't mean humans aren't strictly governing that airspace from the ground.
And here's how regulators actually distinguish you, the everyday hobbyist, from a commercial operator. A model aircraft is specifically defined as a small UAS flown strictly within visual line of sight. There's that LOS acronym popping up again, and used entirely for sport, recreation, or competition. The very second you step outside those specific parameters, you are entering a whole new world of commercial aviation law.
Which brings us to a really important concept, risk.
The handbook clearly delineates between voluntary and involuntary activity. A voluntary activity means you consciously made a choice to put yourself at risk, like taking a job as a UAS crew member or, deciding to go recreational paragliding. Involuntary activity, on the other hand, involves the general public on the ground who made no such choice. Aviation safety rules are heavily skewed toward protecting the involuntary public from the kinetic energy of a falling drone.
And this brilliantly illustrates the massive, complex web of operations currently happening in our skies. We've got governmental state flights for customs and border guards. We have commercial air transport and non-commercial area work. Every single node in this ecosystem is governed by the definitions and acronyms we just went over. Without a standardized vocabulary, trying to manage this web would be absolute chaos.
Section 4. Classifying unmanned systems, weight and autonomy.
So how do regulators actually put all these different flying machines into specific legal buckets? Well, they rely on two main metrics: how independently the machines think and how heavy they are. First, let's look at autonomy. There are three primary levels here. Remotely piloted is what we're most used to. A pilot is directly controlling the stick. Semi-autonomous means the human is just giving high-level waypoint commands and the aircraft does the actual flying, while the human acts as a decision-making monitor. But fully autonomous, that is where the aircraft handles everything, unforeseen events, system health checks, without any human intervention whatsoever. As you can imagine, the moment a drone becomes fully autonomous, entirely new and massive regulatory hurdles pop up.
Next up is classification by weight. When you break it down structurally, systems are classified from Class 0 all the way up to Class 3 based on their MTOW, maximum takeoff weight. A Class 0 drone is under 25 kilograms and stays below 1,000 feet. But a Class 3 system? That's a massive aircraft weighing over 2,000 kilograms, flying in the long-range airspace above 30,000 feet, literally sharing the sky with commercial airliners.
So, the crucial point is, where exactly do regulators draw the line? Well, in the European Union, this number right here, 150 kilograms, is the exact dividing line. If a remotely piloted aircraft has a maximum takeoff mass of more than 150 kilograms, the regulatory responsibility falls to the European Aviation Safety Agency, or EASA. If it's under 150 kilograms, it's managed by the relevant national aviation authorities of individual countries. That single weight metric completely changes the legal jurisdiction.
And finally, Section 5. The future of flight, why getting it right matters.
We've gone through a whole lot of definitions and classifications today, but why does this actually matter for our future? Because the technology is racing forward at lightning speed. We are moving toward deploying swarms, yes, entire swarms of micro-air vehicles that operate collectively. We're seeing the rise of higher intelligence systems capable of SLAM, simultaneous localization and mapping, which allows drones to map complex, unknown environments in real time. And thanks to micro-electromechanical systems, or MEMS, the hardware is shrinking to microscopic levels, while battery technology is pushing flight endurance to new extremes.
And let's be honest, there is an enormous financial incentive driving all of this. $80 billion. That was the estimated value of the international UAV market by the year 2020. With billions of dollars pouring into both military and civilian sectors, from inspecting infrastructure to emergency response, standardizing this alphabet soup isn't just some dry academic exercise. It's a high-stakes, multi-billion-dollar global priority. Without a shared vocabulary and legal framework, this industry simply cannot scale safely.
Which leaves us with this final, provocative thought to chew on. We've seen how the need to emphasize the human pilot evolved our acronyms from UAV to UAS to RPAS. But as these systems inevitably move from being remotely piloted to fully artificially intelligent and autonomous, how will our vocabulary and our laws have to adapt next? When the man in the loop is finally removed, who or what will the rulebooks actually govern? Thank you so much for joining me on this explainer. Keep looking up, keep asking questions, and I'll catch you next time.